All right, here we go. This is what's called try to film a video in 17 minutes. So we're gonna see if we can do it. I think we can do it. All right. 8:08, 8:09. I got till 8:25. All right, here we go. Congruent triangles, part 1, lesson 3, unit 2, page 185. Let's use transformations to be sure that two triangles are congruent. 3.1, true or sometimes true triangles. Okay, if triangle ABC is congruent to triangle A prime, B prime, C prime. So first thing, just rewrite that. Triangle ABC congruent to triangle A prime, B prime, C prime. What must be true? Well, let's do angles and sides. So angles, okay, there's gonna be 3 of them. Sides, there's gonna be 3 of them, right? Because the triangle has 3 sides and 3 angles. Okay, so the angles. Remember, order matters. So A has to be congruent to A prime. So we'll just say angle A congruent to angle A prime. Angle B, second one in the order, is going to be congruent to angle B prime. Angle C, third letter in the statement, congruent to angle C prime. Now let's look at the sides. AB is going to have to be congruent to A prime, B prime. So AB congruent to A prime, B prime. BC is going to be congruent to B prime, C prime. So BC congruent to B prime, C prime. And then last but not least, AC, the first and third, it will be congruent to A prime, C prime. And that's it for that one. That must be true. Angles, got 3 of them. Sides, 3 of them. What could possibly be true? Well, the triangles could be obtuse triangles, acute triangles, right triangles. They could be scalene triangles. What else could we say? I don't know. They could be 30, 60, 90 right triangles. Anyway, you can get creative on that. Number 3, what definitely cannot be true? Well, let's talk about the angles again. And then let's talk about the sides. Order matters in a congruent statement. So order matters. That's what we learned last lesson. So A, B, well, this is gonna be, we're gonna have some debates here, but I'm gonna say, well, they could be isosceles. That's where I'm tripping up a little bit. Isosceles, they could be equilateral. What definitely can't be true? Let me see. I'm gonna probably mislead you on this, but what I'm trying to get at is this is gonna be up for debate. I gotta look at the teacher manual, because I was about to say like angle A cannot be congruent to angle C, but that's not necessarily true, because what if they are equilateral? I was gonna say AB cannot be congruent to BC, but that's not necessarily true. What if we had an isosceles triangle? So I'm gonna have to look at that one, see what the book says, but we'll talk more about that in class. Anyway, number 3, save that for later. In the interest of time, I gotta move on. All right, invisible triangles. So you got this thing. Basically what you do is you're either the recorder or the transformer on this. So we'll go A, B, try to capture all the markings as well. 1, 2, 3. 1, 2, get that C in there. Connect the dots. Okay, so let's start with card A. In order to get from ABC to DEF, all I gotta do is translate. There's just one translation. And I'm gonna say A to D. So translate via AD. You could have also said BE, or you could have said CF. All right, that's the first one. Okay, second one. ABC, DEF. I'm gonna go A to D. I always like going to points that I know are gonna correspond. So A to D. And then I think we're just gonna rotate. Yep, that's it. Okay, so here we go. Translate A to D, rotate center D until C aligns with F. So translate AD. If you want to say directed line segment, that's what you should say. I'm going fast. And then we rotate center D. Looks like I went counterclockwise. Just triple check. Yeah, counterclockwise till C aligns with F. Counterclockwise. And you could have also said by angle C prime D F, because that's the angle right there. So I'm going to say angle C prime D F. It's precise. All right, let's go to C. So we got the card here. Ooh, I got like 7 minutes. That's what I call extra time. Oh, it's a little smaller. Dang it. Gotta do another one. Of course they did that to you in the last one. All right. Why couldn't they just keep it the same size? Oh well. All right, so ABC. Let's go A to D again. rotate. The angle is going to be C prime D F again. And we're going to go, wait, hang on. Okay, so A to D. Yeah, let's rotate so it's like that. What do I gotta do next? Hang on, let me think. Why don't we go B to E, rotate counterclockwise. Yep, counterclockwise, the angle is going to be A prime, B prime, D. And we're here, and you just gotta reflect. Okay, so translate. That's how I'm gonna do it. Translate, there's probably multiple ways, I'm sure there are. Okay, so translate via DLSBE, rotate counterclockwise, center E, angle A prime B prime D, A prime B prime D, and then you'll be here, and then you reflect over DE. Okay, that's the second one. Oh no, I only have 5 minutes. What am I gonna do? Just kidding, it's all good. All right, that's called invisible triangles. It's pretty cool. Noah and Priya. All right, here we go. Why do they coincide? Noah and Priya were playing invisible triangles. Yeah, everybody likes to play invisible triangles. Does that ever happen? Yes, it does in class. For card 3, Priya told Noah that in triangles ABC and DEF, AB congruent to DE, got it, there's your one. AC congruent to DF, hey, they both have 3. BC 2, EF 2, okay. Angle A 3, angle D 3, angle B 2, angle E 2, got it. Angle C 1, angle F 1. Okay, so here are the steps Noah had to tell Priya to do. Hopefully it's one of these. It is. Hey, it's that one. Cool. I think. Yeah. Same labels too. Sweet. And switch it on me. It saves me time. All right. So Noah had to tell Priya the moves. So translate ABC. Okay, here's ABC. By a directed line segment from A to D. So A to D. So there you are. Rotate the image using D as the center so that A double prime, B double prime, and DE line up. Okay, so second move, that becomes A double prime, B double prime. Okay. Reflect the image over DE. That looks awfully a lot like the last one. Okay. After those steps, the triangles were lined up perfectly. I agree. Now Noah and Priya are working on explaining why their steps worked. That's the big part. They need some help. So first, we translate ABC from A to D. Now this is A prime, B prime, C prime. Point A prime will coincide with D because we defined our transformation that way. True. Then we rotate the image by the angle B prime D E. So we're going to rotate it this angle. That makes sense. Okay, so now we're here. Didn't even have to say counterclockwise because the angle nailed it. So now, that was our second transformation. So we're here now. We know that raise A double prime, this one, B double prime, and DE line up because we said they had to. But why do points B prime, double prime, and E, so B double prime and E, have to be in the exact same place? Well, if we translate there, rotate there, these have to be in the same place because these triangles are congruent. Sides all the same, angles are all the same. So therefore, if A double prime is on D, then B double prime and E will be in the exact same place because the triangles are congruent. And A double prime D line up, and DE is congruent to A double prime B double prime. How do we know the image A double prime, C double prime, and DF will line up? So this one. Well, because we know that A and D are corresponding. These are the same length. All the angles are the same because they're congruent. Congruent triangles. And all sides and angles are the same. Why will C double prime and F line up? Well, because they're congruent. Because they're congruent. And a series of rigid transformations if done correctly all corresponding parts, we'll just say all corresponding sides and angles will align. It's a good word. All right, I gotta go. I gotta post this video. It's 40 seconds over, and now I'm late. Oh well, who cares? All right, have a good day.